this will be the third question for dynamics. Okay, this is a long question. Okay, come, let's look at the question and analyze what are the important things. Okay, same thing as before, take note of the mass. Okay, start from rest on the straight road. Start from rest, so the speed will be 0. Constant acceleration. Okay, for 12 seconds. Okay, and here we have again constant speed. Okay, like I mentioned the previous two questions, constant speed implies acceleration equal to 0. Okay, then you have a constant braking force for the last 4 seconds. Okay, so now draw the speed time graph. Okay, so take note for this question, same as the previous one, we combine actually kinematics with dynamics, so it's a very common trick. So here I will really highlight again. Okay, for speed time graph, two things that we are interested, it will be on the gradient, okay, and followed by the area under the graph. Okay, area under the graph will give us distance, okay, whereas gradient will give us acceleration. So these are the two important facts that you need. Okay, so the questions ask us to draw the speed time graph. So I have the first 12 seconds. Okay, first 12 seconds is a constant acceleration. So it starts from rest, so the first point will be here. Start from rest and it ends at 12 seconds somewhere, but I do not have the number. At 12 seconds, what is the speed? So means I will need to do some working to find out the number. Okay, so if I have acceleration, I have time, the easiest one is to use Kinematics Equation. A equal to V minus U divided by delta T. Okay, so if I know the acceleration is 1.5 for the first 12 seconds, final speed is unknown, initial speed I know I start from rest. So if I rearrange the formula, I will have V equal to 18 meter per second. So which means for the first 12 seconds, the maximum speed I'm looking for is 18 meter per second. So it's roughly around here. Okay, so roughly around here. So constant acceleration for VT graph, it will be a constant number, meaning it will be a straight line, followed by the next 4 seconds is constant speed, so it's a horizontal straight line. Okay, horizontal straight line. Then the last 4 seconds, I have a constant braking force to reduce it to at rest, so it will be decreasing speed. The speed will be decreasing until it hits 0 at 12 at time equal to 20 seconds. So it's more or less like a trapezium. Okay, this will be a trapezium. Okay, same things to take note is, like I mentioned before, okay, the area under the graph here will be the distance traveled. So it will be the distance traveled. Okay, then as gradient for each segment here will be acceleration for each segment. Okay, so this will be answer for your part A. So how about part B? Part B is I want to find the resultant force acting on the object. Okay, resultant force acting on object. Okay, give me a minute. So resultant force, same thing, Newton's law, F net equal to ma. Okay, so now the question is resultant force means I want the left hand side. So if I have mass for the first 12 seconds, acceleration is 1.5, I can just substitute it inside the equation. So the mass is 800, acceleration is 1.5. Okay, punch my calculator, I should get an answer of 1200 Newton. Okay, same thing. Okay, so what is the acceleration force? What's the resultant force for the 12 to 16 seconds? Same thing, F net equal to ma. Okay, so these two parts is quite similar. Okay, F net, but think you note what happened during the 12 to 16 seconds. Let's go back. Okay, for this segment here, 12 to 16 seconds, the difference is that at 12 to 16 seconds, the acceleration is given by the constant speed. Okay, so which means that actually for 12 to 16, if I have constant speed, my acceleration will be 0. Okay, so please take note, because the question says that it is constant constant speed. So which means at this junction, this will be A equal to 0 because 3 dot because of constant speed. Okay, so this is a trick that we always use. Constant speed means acceleration equal to 0. So if you put 0 inside the equations, you'll find that the resultant force for 12 to 16 seconds will be 0 Newton. Okay, this will be a straightforward answer. Okay, not much calculation needed. Okay, so what is the explanation? The explanation will be given here. Of course, students, please write in words. Keywords that we are looking for is two keywords. One is resultant. Give me a minute. Okay, one of the keywords that we are looking out for is because it's constant speed. Okay, so the first keyword we are looking for is acceleration equals 0. Then the second keyword we are looking out for is, remember, we must write F net. Okay, in words. Okay, so in words it will means okay, let's see if I write in words. Okay, so the second keyword we are looking for is actually net force, or what we call resultant force. Okay, is 0. Okay, so the keywords that we're looking out for is these two keywords. So in your explanations, you need to state that because it's constant velocity, okay, the acceleration of the object is 0, and thus the net force acting on the object will be 0. Okay, so important fact. Okay, just now first two questions we see this in calculation, now we see this in your explanations. Okay, so please take note of the keywords. Part D, describe how you calculate average speed. Okay, so before you write this, you need to recall the formula. Average speed based on kinematics. Okay, it will be total distance divided by total time. Okay, so here you need to bring in your kinematics. Total time you given is 0 to 20 seconds. That's the total time. So how to find the total distance? So in your answer to describe, you need to tell the marker how to find total distance. So you need to tell the marker in words. Total distance can be found where? It will be under the area under the graph. So this will be one of the keywords in your answer. Okay, so area under the graph, okay, for 0 seconds to 20 seconds. So the keywords that we are looking out for is actually area under the graph. Okay, so this will be the keywords that you're looking out for the first one mark. Okay, then after that, the second mark is when you tell the marker to say how to use the formula. So you need to tell the marker saying to find, then how to find average speed. Average speed can be found by dividing, okay, the total distance with the total time. Okay, so basically just we need to restate the formula in words. Okay, so this will be the second keyword, which is actually the formula itself. Okay, so this will be the second keyword, which is actually the formula. So this is how he actually uses keywords to answer your question. So keywords is this, keyword will be this is one mark, and this will be a second mark. So this is how I convert my explanations to keywords, and which keywords actually carry marks that is needed. Okay, and these keywords we have is actually in in chapter 2, kinematics, but more often we see kinematics combined with dynamics chapter 3. Okay, so students, please take note of this. Okay, with this will be the last question for dynamics. Okay, hope you manage to learn some of the things. Okay, if necessary, look at question 1 and 2 again. Okay, thank you. Bye bye.